Welcome back. This is the second um, video of our series about consistent hashing. I guess we have only one more video after that. In the previous video, we talked about the rehashing problem, and we talked about that we had a table that when we used to hash our clients with our servers. The problem that comes with this approach, that if one of the clients is changed or one of the servers is changed, all of the keys are changed, all of the keys are assigned to distributed to most of the keys. Let's not just all, most of the keys are distributed to different servers, and this causes a lot of missing caches for the client, and it's not good in scalable projects because it make a problem with the latency, make a problem with the reliability of the component. We want to build something in scalable way. So the solution for this problem is that we create something called a consistent hashing, and let me make this square by. Okay, let's just imagine that we have this circle, and the hash function positions our servers in this circles based on IP address, for example. So let's just assume that we have 4 servers. So we have this one, it's S0, and this one is S1, and this one is S3, and this one is S2. S2 and S3. Sorry, this one is. Let's just. Okay, this one is S2, and this one is S3. Maybe the hash function will position our servers based on the IP address. And we have the clients. Let's just put our clients. So basically we have C0, and we have let's say that we have C1 and C2 and C3. Using this way, before I go to a description in this problem, just have to mention something, that the way that the hash function of this specific algorithm works way more different than the rehashing problem that we did in the previous one. So there is no modular and there is no mod. We're not modding anything. We just do it. We just position the servers based on the IP address. So let's just say that how we connect the clients with the servers. Let's just hit this one and make it yellow here. So we go clockwise. So C1 will be with S0, and C1 will be with S1, and C2, client 2, will be with server 2, and client 3 will be with server 3. By this way, everything looks fine, and I guess one of maybe you're thinking, okay, why we're using this? It's what is the difference basically between this solution and the previous solution? The previous solution was working, but we got the problem with the previous solution. When we delete or add servers, our problem that we are redistribute all of the keys. So let's see if we add servers in this solution, in this specific solution. Let's see if we redistribute all of the keys, or what will happen. So for example, let's just add a new server. Let's add server here. Let's add server here. Okay, so let's just add a new server here. It will be S4. So as we said, we only go clockwise. So when we go clockwise, when we go clockwise, let us and let's just make the client 0 quite far away, so we can just yeah. So we said that C1 was connecting with with S0, but we go all the time clockwise. So C0 we will connect with S4 because it's positioned before S0, and we go to clockwise. So if you see here how what will happen, the C0 client 0, it's only affected basically. We only distributed C0, and we didn't distribute C1 and C2 and C3. All of the other keys remaining the same. The only one was changing is C0. This is the only one that was changed basically. So in this one, it's better in adding. Let's talk about in deleting. So let's delete different one. Let's delete. Let's just take another color, and let's delete S2. Okay, let's delete S2. So what will happen? We will go again clockwise. So C0 continue with S4, C1 continue with S1, C2 will go, instead of S2, there is no S2 basically, so C2 will go to direct, sorry, my handwriting is awful. So C2 will go and connect with S3. Just again, last time. Yeah, okay. So C2 will go and connect with S3. And by this way, the only one was affected is C2. C2, we only redistribute the client 2, and that's it. We are not redistribute everything, and this is the bar for come from this one. However, in this problem, in this approach, it seems pretty good, straightforward, but we have two problems. One, let's create another circle, and let's just has one is that we let's just have these servers. Let's have this server and S0, S1, S2, no, go back, S3. And one of the problems that we actually have, if we deleted S2, if S1 was down, it's impossible for us basically to keep the same size of partitions on the ring for all servers. Basically, the partition is the hash space between each server. So sometimes it will become too big, or sometimes it will be too small. For this example, we have this. It's like that. It's too big, and with these two servers, it's too small. So there is no. It's pretty impossible to make sure that the spaces is in the middle. That it's sometimes become too big, sometimes become too small, because we add or remove servers a lot. The second problem that we could have also is that we have non-uniform key distribution. So we just put the keys based on the IP address. We just throw the keys anyway. So this could cause a problem that if we maybe have multiple clients here, like so C0, C1, C2, and C3, and we all the time go clockwise, we will find the problem that S2 will take all of the traffic of these 4 clients, and S3 and S0 will got no traffic at all. And basically these are the two problems that we are facing with this specific solution, and we will come up with the way to solve them in the next video. We will talk about the virtual nodes and how to make sure that it's effective basically. And that's it for today's video. And if you like my solution, make sure to subscribe, hit the notification bell so you'll never miss a video, and give me thumbs up. And if you didn't like this video, just comment below and tell me what the thing that you think that I should improve, because we are learning together and we're learning to eat with each other, and I'm enjoying doing this video, and all this in the same time also I'm studying to be able to be better in these videos. So I hope that if we communicate with each other, our community will be bigger and bigger. So that's it for today's video, and see you in future videos.